Thank you, Elliot. We'll continue in English, actually, since
Very kind.
yeah, I mean, you're good at Finnish, but maybe it's more fair. The slides are in Finnish, but we'll cover this mostly in English. And before we start, like the topic is 6 effective ways to break a perfectly good Wi-Fi network, and at least to me, it looks like we haven't broken anything yet, cause I think the Wi-Fi actually here seems to work, right? Even on 2.4, it's not looking that bad. Sure, there's a lot of APs here, and there's some code channel interference here, but most of the clients seem to be on 5 gigahertz because the channel utilization is not actually that excessive, and the number of networks, not to blame anybody, but Jaro iPhone 14 Pro is using 1 megabit data rates. So yes, hey Jaro, nice to see you, man. Okay, but yeah, it looks good. Looks good on 2.4. Looks really solid on 5. So certainly, at least the Hilton guys here have not broken their Wi-Fi network. But let's take a look at a couple of ways how to break it. How about that?
Why not?
And we brought the expert of breaking net. We have 2 experts in breaking networks here on stage now. So.
Making stuff not work.
Exactly right. So yeah, now tell us a little bit about you. All I know is you're from the UK, and in the UK, this is what happens, right? Not to be stereotypical at all.
No, absolutely. The only thing is the AI hasn't quite got this right, because if someone gave me a pint like that in the UK, their heads would roll.
Oh yeah, well,
yeah. You just have, because then I've got less beer.
Ah, okay.
See, so.
Got it. And it seems like a pretty small beer as well.
Oh
you
yeah,
drink
it
that,
needs to
you?
come in at least like a Colosseum or something that I could drink. Or
There you go. So you used to work for an MSP, right, in your previous life, and you've worked for Apple and stuff like that.
Yeah. I've been around the place. Yeah. Absolutely. So worked in a kind of like systems integrator, VAR, MSP, all that kind of stuff. And I've got all the scars to kind of show for it as well. Mm-hmm. So kind of integrating this stuff is, where I've been for a lot of my time.
And you've also, like during your MSP days, you did Juniper, you did other brands. Yep. You started off, when you inherited the MSP practice, you started with another Wi-Fi design tool.
I did.
And then
I started using this one.
Yeah.
And I thought, why am I stuck in 1997? And
you kind of transformed the entire practice around Hamina and quite a bit of Juniper as well. So.
Yeah, exactly. And actually, the 2 things kind of came hand in hand, which was quite useful at the time. So kind of transformed the way that we did kind of designs. We used to design kind of make people pay up front and all this kind of stuff. But actually then we ended up moving to doing all the designs for free. And we ended up winning a lot more business because we did that. Yeah. Nice.
Yeah. For those of you I haven't met, I've met probably most of you. I'm Jussi. I come from Finland. This is what we have here. And I also work with Hamina Wireless. Thanks to Dan's temporal moment of insanity a few months ago, you now work with us as well. So glad to have the pleasure of that. So I've done 20 years in wireless tools, and the common question I get is, Jussi, dude, you old. How long have you been involved in Wi-Fi? And the answer is this long. This long. Anyway, we do have a demo room back there, which probably right now is unoccupied, but we'll all be there during the breaks. If you want to see demos, talk about wireless design, troubleshooting, all of this kind of stuff, we'll be there hanging out. We'll have several laptops, displays for demo stuff like that. We also have Hannele Mammele Antila here from our marketing, as well as Timo Turkki, our integrations architect, who's actually responsible for a lot of the Juniper integrations that you will see today. We'll look at the Juniper integrations in depth in the afternoon. We'll cover a little bit of that, the Hamina Juniper integrations now doing this presso, but we'll look more of that in the afternoon. We'll be there.
And that's why we bought Timo, so that when you ask us really hard questions that we actually don't know how it works, we can point you to him. And
which is all questions for
exactly.
my
Also,
this is LinkedIn. Snag a picture, connect on LinkedIn, and we're there. We post a lot of like videos, this kind of content on Wi-Fi, and we nerd out there as well. The usual train wreck warning. This is not exactly scripted. We do not have a prompter. It's gonna be inappropriate and probably terrible. So just so you know. Okay, but let's start with 6 problems with Wi-Fi, right? And maybe the best way to like break a Wi-Fi network is just slap APs like somewhere, anywhere, right? So an example would be maybe a retail store.
Yeah, I call this the wet finger in the air design.
Precisely right. And
that'll do.
It probably would seem like a good idea. Let's just, place the APs where we have power in the corner, stuff like that. And then we'll go from there. And if you do this blindly, if you don't have the tools, then, obviously you'll end up with something like this. And, this is not just the tools. This is also like probably pays off going on site whenever you can. And you used a lot of video to like have either the customers take videos of the site or...
We've tried loads of things to try and get some sort of information. Getting customers to snap photos, videos around the place, just to give us an idea of what's going on in the environment, I guess.
Exactly, and I think the biggest, like you mentioned this briefly, how you started making plans for free for all of your customers. I guess because it was more quick than before, right?
Yeah, a lot quicker than before. So the point is that we were kind of, before we even engage with someone, we were asking them for money. We were asking them to commit to something, and they didn't know what the kind of cost for the project would be, right?
Yeah.
So what we kind of did, we flipped that on its head and we went, well, look, it now takes us, a very short amount of time to quickly make a design. Let's just do the design, give them the actual BOM that they'll need. Then they know what they're going to commit to, and then we win the kind of hardware business and all the professional services after that too.
That worked out pretty good, right?
It did work out pretty well for them, yeah.
So and I think one of the fears is like, it takes me a lot of time, it's complicated, all of that, but we've kind of tried to address this like on a browser. It took me literally 7 minutes to do this modeling. I just put in like the shelf heights, like how high are the shelves, 2 types of different shelves. Click through the shelves. 7 minutes later, you have something like this. It looks like, but you have to know CAD and stuff like that. But everything works actually in 2D, right? Well, it was fully 2D for the longest time. When you started using this, there was no 3D functionality.
Exactly, yeah. And I think like in terms of the way that I kind of say it to people is like, this is like an order of magnitude, right? So this has taken me 10 minutes to make for you. This is an order of magnitude of what you'll need in terms of the BOM. Okay, you might need slightly more, you might need slightly fewer, but actually this is a really good rough cost of what you're going to need to get you going.
Exactly right. And for example, on a retail store, like at least this one I think was pretty well made. The APs were in the ceiling, they were at the ends of the aisles, stuff like that. Any caveats that you would see in typical, let's say, retail office, things like that? What are the, like, AP placement wise, AP design wise, like what would be the worst things you can do?
I think one of the biggest things is when you've just got like a big open space, right, is kind of how are you sorting out the kind of roaming for those devices, right? Because is the signal just going everywhere? All those types of things. So like one of the things that I've been doing a lot of recently has been things like, okay, well, rather than put the AP on the ceiling, why don't we put the AP under the desk? Because then we can put bags of water around that AP and contain where that signal goes, right? So now we can start to control how the device roams. We can kind of show them how the device will roam, that type of stuff too.
Exactly right. And you actually presented on the APs under the desk stuff because it sounds so counterintuitive. You actually presented on it.
Like we said, I know how to break things, right? So
let's see if we can actually find it. But it's there. It's there on YouTube, right? Your presentation at the WLPC conference on this whole thing, 10-minute presso on why place APs under desks? What does it mean? How does it work? And if you go to places like high-end stores, like Apple stores, you look under the very they don't have this in Finland, but you look at the under the very fancy desks they have, for example. They've done the exact same thing, and the thing is you get the clients really close to the APs, you get amazing data rates, and come time, for example, for an iOS, you know, they release the new iPhone, the store is completely full, all of the phones are updating while they, you know, configure them for the customers, it still works.
Yeah, and you know that there aren't going to be people stood on the desk, right? So, so you know that that's an area where you're not going to have a big bag of water in the way, and it's going to work well.
Exactly right. So some kind of a design probably makes sense. Maybe that's obvious, but here's the second thing: painted green. So just, you know, we see this a lot in like hotels and stuff like that, where you just slap the APs in the hallways and then you max out the transmit power,
Turn
right?
Up to 11.
Yeah, exactly. Turn it up, and I think you have the remarkable there as well. I'll try to show it on my screen as well. But
you're going to make me draw something now. Okay.
Let's see. Does it actually? Let's see if this.
Let's see if it works. Right. So this is my AP. Oh, here's my AP. All right. So here's my AP. Firing stuff out. So the thing that you've got to think about when we're thinking about, you know, just making a floor plan green is, okay, well, we can turn up, you know, the AP really loud. We can max out. We can go to 11, and that kind of like fires out this like horrendously loud kind of signal, right? But then we've got this tiny little, say in a retail environment, we've got a tiny little scanner. This is my Bluetooth scanner. I am terrible at drawing. I don't know why he's
you're doing great, man.
Yeah, cheers. And you know, this is firing out like really, really loudly, and then we've got, say, like a 4 dB kind of pushing back from the scanner, right? So you've got this kind of crazy weak signal coming back from the client device, this really loud thing coming back. And I know what you'll say. Yeah, but the AP's got a, you know, much better antenna. It can hear better. Okay, but it's still in balance, right? So we have to think about how we can make sure that we've got this kind of synchronous kind of thing happening between your clients and the APs.
Yep.
And that's one of the things that we've made sure that we've been able to show people, right? Is not just how the clients are hearing the AP, but actually how is the AP hearing the client back?
And this is kind of the most one of the most underlooked and undervalued things in wireless design. We've always used to looking at one way only, right? Whenever we do a plan, whenever we do a site survey with one of these, like it's always been like the downlink signal only, right? Yep. Just the downlink. We never consider the uplink, although the weak link typically is uplink, and that's why you want to use systems like Juniper, which also picks it up from the AP side.
Yep.
But definitely you want to consider both directions. I wonder if do I have? Let's look at the retail store then. So we'll go back here. We'll do a design. You know, we'll scrap that and. I hope you can see the small numbers. I'll try to make it a little bit bigger. So let's look at, I don't know, 5 gigahertz, and you said 25 dB, like we'll put 23 dB, something crazy like that. And we'll put them on, I don't know, 5 meters height, 4.5, something like that. And then, you know, sure, the coverage is pretty freaking great downstream with just a handful of APs. This is a fairly sizable retail store. So yeah, what we're looking at now is downlink. But let's look at a pretty standard, let's say an iPhone first, like a high quality radio. So this is like, you know, pretty new iPhone, 10 dBm transmit power backstream. It's already pretty bad. But then let's go to your scanner situation, right? Which can make it significantly worse. So you said what, 4 dBm?
I've had a 4
there we go. So now the uplink, look at the difference. That it's just, that's pretty brutal. So yeah, sure. It's easy to paint the map green, downlink. Look at that. It's pretty green, but yeah, uplink, there's terrible things happening. So yeah.
And this is something that, you know, a lot of people aren't taking into consideration.
Yep.
They make the maps green. They've used fewer APs. They're happy with themselves. You know, we've managed to cover everything we needed. We don't necessarily need capacity. We just need coverage. You know, so let's turn them up. But actually, you end up then with the clients.
Absolutely. And the other thing would be like 2.4 versus 5 versus 6. Sure, the iPhones and the modern iPhones, modern MacBooks, they do prefer 5 gigahertz over 2.4. They do prefer 6 gigahertz over 5 gigahertz. But still, like, you might have those scanners and stuff like that are not as smart in terms of their roaming behavior, and they just might get stuck. And you can, certainly you can visualize it here. And by the way, here we can also see what happens. Like, there's an enormous area. Like, you walk into the store and you're pretty much stuck in the one AP unless you're lucky enough to go back here. So yeah, to illustrate your previous point at the same time. Okay, what else? So maximize the gigabits per second, right?
Oh yeah, power,
speed, wider channels, 320 megahertz, Wi-Fi 7, right? So what's going on here? Because we want to see the high data rates, right? You just said, like, clients need to be close to the APs to get the high data rates. So what is the typical mistake here?
Well, again, I think that there's a discussion to be had right on this, because I think, how much CCI is too much CCI? That's a good question to kind of start with.
Exactly,
right?
And by CCI you mean channel interference, right?
Yeah, exactly. So APs on the same channel, things like that. In what instance is that a good thing? When is that a bad thing, right? So
exactly right. Let's illustrate the problem first.
Yeah.
How about that?
I think that's a good shout.
So to maximize the data rate, we would use 160 megahertz, the widest channels possible, which might be the default even in some Wi-Fi setups that you use. So sure, like coverage looks great, data rates look great, but what starts to happen if we look at channel interference? The tool that we're using is automatically all the time optimizing the ideal channels into the network.
We should show the channels. So that
we should. We really should. So you can see it's. Oh, did I put it on manual channel planning as well? There we go. So it's trying its best to kind of optimize the channels, but no, because there isn't any free channels. That's the problem with 160 megahertz. There just isn't any. That's kind of the key issue here. So what we want to do is probably utilize something a little bit narrower.
Yeah,
right?
use as wide a channel until you can't, right? That's the kind of idea. So try and get as much data rate with the channels you've got available until you can't, until you cause too much interference. But what I would say is something like in 6 gigahertz, you might want to say, well, look, I actually don't mind if there's a bit more kind of interference, right? I'd prefer to because there's fewer clients on 6 gigahertz at the moment, let's allow a couple of APs to be on the same channel. Let's allow that to happen, because what we want then is people to get on and off the air as quick as possible. So then we can kind of build in some margin that we've kind of got around that, right? So we can say we don't mind certain.
Yeah, we don't mind a little bit of channel interference, but more than that we probably don't. So look at 6. There we go. So for 6 gigahertz, we allow a little bit before we start reducing the channel width, right? So just allow it a little bit, then switch the channel over. Allow a little bit more, then switch the channel over. Let's look at the slightly larger environment here. So initially, when we place the first radio, it's 160, right? Because it makes sense.
1 AP, may as well go as wide as you can.
Exactly. But once we start putting more and more, and now, we work our way around the channel interference as long as we can. But pretty quickly, 5 gigahertz runs out of free channels, depending on your channel setup, of course. So depending on your country, whichever channels you have allowed, we have disallowed Uni4, for example, in this case. But when you start running out, we start to kind of make the channel width narrower and narrower and narrower. But the thing is, I agree with Dan. I would allow a little bit of channel interference maybe. So this controls the setting of when do we start making the channels narrower. And of course, it's global in a sense that across the map, we use the same channel within all the APs, right?
You definitely don't want to have, a couple of rooms with 80 megahertz wide channels, different APs with 20 megahertz wide channels, because that's where you'll get issues with things like Apple devices, right? Sticking to that AP that's got a much wider channel. So yeah, we're doing it across the board. So we're bringing every AP's channel, width down at the same time.
Exactly. And here we can, for example, see 6 gigahertz channel width changed to 80, but it didn't do it very quickly. We had a pretty dense design here, and only when it started to see a lot of interference did it switch it. Let's go back to this guy. Look at interference. So allowing a little bit of interference like this would probably be fine, right? If there's two APs audible in the hallway at the same time, but I get twice the data rates.
Yeah.
It's probably a pretty good trade-off in most cases. It might increase your latency a little bit, but is that really so significant? Even Zoom calls, everything would work really, really well in this environment.
Yeah, I think so. And I think like the kind of thing that we're kind of trying to get across is like, you don't just have to go straight to 20s, right? Like the whole point of using a platform where you can see what's going to happen is you can try and make that kind of decision based on the type of environment you've got. So if you've got, student accommodation or something like that, you might want to have wider channels so that, people can get the data quicker and then get off the channel and not be on the air.
Exactly right. Then the next thing was all Wi-Fi 7 is created equal, right? And this isn't so much of a problem in typical enterprise APs, right? But you want to be careful, and especially come next year, we'll start to see all kinds of shenanigans when it comes to Wi-Fi 7 and marketing.
Yeah, marketing. Hannele. One of the crazy things that we've started to see already is that something can be Wi-Fi 7 and not 6 gigahertz, right? So we just got to be super careful on what's actually we're putting in, what we're talking to people about, and I guess even when you're having conversations with people, just making sure that you're talking about the same thing. Wi-Fi 7 doesn't equal 2.4, 5, and 6, right?
Exactly. So we'll start to see, especially in home, SOHO, and maybe SME APs that claim to be Wi-Fi 7, and they are, but they do not support 6 gigahertz. So be very careful with that. Don't just take the specs and run with it.
And what type of MLO is it using, right? What type of kind of features has it handpicked from the standard and then just called itself Wi-Fi 7? So, even down to things like channel widths. We've seen the iPhone 16 that's just come out is a Wi-Fi 7 device, right? But it doesn't do any Wi-Fi 7 things. It's basically a 6E device that they've called Wi-Fi 7 because it's easier for people to understand the difference between Wi-Fi 6 and Wi-Fi 7 than it is Wi-Fi 6 and Wi-Fi 6E.
Exactly, and the relevant thing came already in the previous generation, which was 6 gigahertz support for the iPhone. So as long as you have that, that'll do it. And why Wi-Fi 7 and 6E obviously are as important as they are. I think we've gone through this previously here as well, but essentially when you start to have a boatload of devices, I'll just say like this area is crowded with devices, then distributing those client devices between, let me just enable capacity here, distributing those client devices between the radios becomes more and more important. So this is a ridiculous number of devices, but essentially you don't want the 2.4 and 5 gigahertz radio sharing all of the load. You want the 6 gigahertz radio helping out with your client load. And of course, it depends on what is your client population for 6 gigahertz. Like today, what are we seeing? 20, 30%, something like that?
Yeah. So I think I did an event, 2 events in the same place about a month apart. One, we had 12% 6 gigahertz capable devices. Then the iPhone 15 Pro came out and it went to like 37%.
Wow.
Just in a month, right? And then I had another customer who were kind of Apple first. They had a kind of Apple everything, and their refresh cycle was every 2 years. They now have 100% 6 gigahertz capable clients, right?
Exactly.
So it does depend on the customer. Depends on kind of what kind of stuff they're running, their refresh cycle and things like that. One of the things I was going to say about the capacity one of the really great things that we're seeing from a lot of the enterprise vendors now is that they're doing these kind of software-defined radios, right? So you can take take an AP down that was a previous Wi-Fi 5 AP, and now you've got the ability to do dual 5/6. So something like the AP45, you can now convert that redundant 2.4 radio that we're not really using, you may have disabled kind of previously, and then actually create more capacity on that same space and make it dual 5 and 6. So again, you can do that, select it, and then you can see now the distribution between those two radios. And the way that we do it on our kind of our floor plan, right, is we try to consider the QBSS load. So if
what is QBSS load?
Yeah, okay. So how busy that radio is, that channel is, right? So if we're seeing that this radio, this channel here is really busy, we'll actually use the kind of algorithms within the floor plan and where we're putting the clients, and we'll try to kind of use the kind of logic that they would use to shift them from kind of radio to radio. Exactly. So we might put, say there's a client who's here, which this is the closest AP. If there's another AP that's a bit further away, but has, less capacity on it, it'll actually move to an AP that's further away so that we can spread that.
Exactly. The clients don't only look at the signal strength. They don't only look at signal strength plus the band. They look at the QBSS load, which is advertised in the beacons, and they can say like, okay, that radio actually on 6 gigahertz is the closest one, it would make sense, but it's so crowded already because of all the other devices have done the same decision. Yep. They will then merge, move over to the radio that from signal strength and let's say frequency band-wise wouldn't be ideal, but it has much less utilization, so they will merge there. And that's what we also modeled in the capacity planner as well.
And you can see that if you use the client view, right? So if you do the client view and you stick it in a particular location, what you can see is that the blue line is the kind of one that it's the best one it could go to. Yep. But then you've got these gray dotted lines that go to other APs. That's showing you other APs that client could use. So that's below the kind of trigger threshold. It would have good enough signal, all those kind of things. So you can see when you're building it out, okay, I'm trying to build in some capacity into my design. So I can see here that if this room was full, if this room was at capacity, it doesn't matter too much because I know that the APs that are in the kind of surrounding rooms, they would be able to help take some of that load from that space.
Exactly. And then as a segue on Wi-Fi 7, there's some other, like when you're upgrading to Wi-Fi 6E, when you're upgrading to Wi-Fi 7, switching PoE, all of that starts to play a bigger role as well.
Oh yeah. So hopefully you will know there's a kind of a lot more power that's needed, right, to run some of these newer APs. So what we've kind of also built in is that in the switching, we can say how many ports are free in that particular switch, and we can give you the PoE budget, right? So we can start to kind of say, okay, this is how much power that's going to be utilized in this thing. Do we have enough to just rip and replace our APs, or do we need to look at our switching as well? Do we need to look at how much power we're able to deliver to those APs?
Absolutely. And one of the newer things that we brought recently is the cable trays as well. So you also not only do you want to understand the PoE budget, the port budget, but also where do the cables go, right? So you can see how this is actually a cable tray, and the APs, the cabling attaches to the trays. So not only do you get an accurate estimate of PoE port budget, but also your cabling paths as well as your cabling distances. Not all of you do this kind of cable planning. Some of the, especially the smaller MSPs, they definitely do everything in-house, and it might even be the same person
Yeah, and do you know what? Like the way that I would use this is just to go, here's a rough estimate of what we need, Mr. Installer. Can you give me a quote based on this, rather than you having to go to site and do all that kind of stuff?
Exactly right. So APs, switches, Ethernet cable, how many pieces of cable, what's the length, all of that kind of stuff. So definitely. So what if something still goes wrong? Do we always need to do a site survey with one of these things and all of that, or is there another way to do this? Not that it's a leading question or anything, but
there's probably a more modern way that we could do this. If only we could get the data from the network itself.
Yeah,
kind of
like
present
from
that.
a cloud. If only there was a cloud-based vendor
That had
that
some
could-
sort of way of us taking the data out via, I don't know, APIs or
Yeah,
something
like
like
an
that.
application programming interface.
That would be amazing.
It would be, wouldn't it?
Yeah.
So here's our simulation, right? Here's the typical sandbox, and some of you may recognize this office, including the pool or the ping pong table and the pinball machines. But so this is somewhere in Helsinki, and you can do the simulation. Then you can look at the how did it look when we walked around with our iPhone and get the measurements. So this is real actual coverage at the time it was measured. But usually the tools leave you at this point, right? You do the plan, you do the survey, and that's it. If only. So but if we click, oh, somebody stole my API key, and I can't. I'm on stage, mate.
Nice. Getting your own back.
What? I can't go to my messages here. They might have terrible content. All right. And introducing Joel Crane to fix our AP.
Joel, have you got it on your laptop? Do you want to come up and
Yeah.
show on your laptop?
Yeah, and what's that?
Okay.
My SMS. Excellent. Oh, this is going to be terrible, though. I will just move it really quickly. And see, actually, 2 of my latest messages are from Mikko Lauronen from Ekahau. I don't know if you can see this, but he sent me heart, smiley face heart. And then Joel Crane, just so you know. All right. So what do we got? Oh, there it is. Nobody saw this, and we will delete this from the recording and everything. Okay. So all we need to do, and this is a great demo, right? So all we need to do is put in a new API key, global 01, right?
Yeah.
Excellent. So we just say continue to site settings. All we need to do is put in an API key. We say, okay, which floor plans do we want to utilize? After clicking the live. Let's see, and then we should be off.
Are you zoomed in? Is that why we
I
can't
am
see
zoomed in, aren't I? There we go. Hey, it says syncing AP to AP data, environment learning model updated.
As
And
if by
what
magic.
we're looking at now, after this 2 minutes of embarrassment, we're looking at live coverage of the network per AP. For each of the APs, we can see how many clients on each of the APs as well, and each of the radios. So what we did is we pulled everything we can from the Juniper API, and not just like the AP locations, not just the maps, but also the access point to access point signals and things like that. So you do not need to have walls drawn. You do not need to have site surveys. Nothing like that. You can just say, go to live directly. We'll get the maps. We'll get the AP locations. We'll get the RF information, and we'll start to draw live heat maps accurately using only the data we get through the Juniper APIs.
And so just before I joined Hamina, I actually won an RFP off the back of this, right? So there were 400 offices worldwide. I basically said, well, look, for your 8 kind of biggest offices, we'll do a proper kind of survey, do a design, all that kind of stuff, make sure it's kind of proper. But for the other 392, we'll just do a predictive design, we'll install it, and then we'll use this to effectively do our validation survey, right? They were all kind of carpeted offices. We'll use this as our validation survey. Out of those 392, 3 of them weren't quite where we wanted them to be. So we then went to those sites, fixed the problems, and then everything else was great and worked well.
Exactly.
Saved a lot of time, kind of won us the RFP, all that kind of stuff.
And this is, in carpeted spaces, this actually works really well. So if you cannot do a site survey in a carpeted space, floor to ceiling walls, it actually is pretty darn good. I wouldn't trust only these heat maps in a warehouse or a factory. You still definitely want to do that site survey there. And what I really like about it is, sure, everything looks green, but let's say there's still still we're seeing problems. Like Emma's laptop still seems to be encountering problems. So let's take a look at where that is. So there is Emma. And using the APIs, we can immediately start to test against the device. We can show where is the device and how is it working at this specific moment, okay? And all of this, the client is not cooperating. The first question is like, what software do you have on the client? Nothing. It runs absolutely, well, it runs an operating system and blah, blah, blah.
There's nothing on it. It's turned off.
Exactly. But it's a standard laptop, no agent software, nothing like that. And we can see like, okay, what's wrong with the device? What's going on? Like a summary, and then everything, retry rates, data rates, everything there.
Why is Emma crying in the server room? She's obviously
because of the bad
someone's
Wi-Fi, right?
Someone's upset Emma.
Exactly right.
She's gone.
Sorry, Emma. But yeah, any device, we can see where they are. Jussi Rintajaskari is in the meeting room. How is the network working? How is the signal strength? When he starts walking out, we can see the roams as he walks around the office. This is live client troubleshooting, so you can get an understanding of the infrastructure, like coverage, secondary coverage, channel utilization, non-Wi-Fi interference, versus Wi-Fi utilization. Live, and then this. So
and just quickly, let's just show that. So the channel utilization. I know you had it up a second ago, but the fact that we can kind of differentiate and show on the map where you've got kind of high Wi-Fi usage, but then also where you've got interference coming in, right? So non-Wi-Fi stuff that's happening. So stuff that's hitting energy detect on the AP, we can kind of map that out and show you that on the floor plan as well. Then you can go, oh, okay, there actually seems to be a problem in this space. Let's go and check that out.
Exactly right. Yeah, and this is kind of like, and this is the beginning, right? But this is where it's going. So these kind of tools, expect these kind of tools not to be just planning tools, site survey tools, but also more and more visualization tools, cable design tools, switching design tools, everything. So yeah, one last thing. Let's say, and I know we're way over time. Elliot went a little bit over time, but we're way over time, right? He's ripping out his hair. He'll be as bald as I am soon. So let's say we actually have surveyed this site, right? So we start with a site survey. Instead of starting with a design, we go and remediate an existing site. So we have an existing network and we want to just rip it out, create a new one, for example, or we want to make minor changes to it. And we wouldn't really want to draw the walls and stuff like that. So let's do that. So after the survey, we just go to the planning side, and I'll just take the APs out. After the survey, and there's no walls being used here or anything like that.
We've not built anything in. It's just a flat floor plan.
And then we start and okay, let's replace this network with a Juniper AP45s. And based only on the survey data, we can start to look at okay, how is the network going to work? Based only on the survey data. There's no walls here, nothing like that. But the system learns using the survey data, like how is the network going to work? How it learns and understands like, okay, which areas are more attenuating, which areas are less attenuating, and builds that predictive model, not using the walls, but using the survey data from your quick walkthrough checkup survey that you probably do anyway when you go to remediate the site.
And what's great about that is that's taking into account things like your reflections, your diffractions, all that kind of stuff that is really difficult to kind of put in and model correctly and accurately within this, because we're using real data that you collected on site and then putting that into the attenuation kind of model. That's where you're then getting a kind of much more accurate kind of
exactly. Previously, you would have needed to do the survey or maybe even do access point on a stick surveys and then kind of try to train the predictive model, draw the walls and then fine tune the walls, stuff like that. None of that anymore.
Nice.
There's a question in the audience. There was a question on, does this feature work using the base license or does it require Plus? First of all, this will be released at the end of the year. So what you're seeing is our test cloud. Secondly, I believe the decision was this one does work on the base license, if I recall correctly. And the cable trays, for example, the cable paths are then a plus thing. If I recall right, was that the discussion we had?
I can't remember. I always go to our website to find out what features are included in which bits.
So should we just make the decision that it will be on the
yeah, there you go.
version? Yeah,
there you go.
So yes, it will be. Yeah. We have 140 witnesses now in front of us.
Don't tell anyone.
Our chief finance officer, our non-existent chief finance officer, will rip his hair out. But yeah, that's some of the ways to break the network. That's some of the ways to fix the network. Miika. That's a great question. Is the live system collecting historical data as well? Can I rewind back in time? And the answer to that is we talked about that, for example, with Sudhir Matta, who heads Juniper's products, and quote from Sudhir was, "Jussi, do not break my API." So we do not store the historical data yet, because that would mean a lot of API calls. Let's say 10,000 customers, and we would collect the history data for everybody. That would amount to like quite a bit of data in the long term. So not yet. But it's something that we're actively kind of brainstorming, thinking. I think we talked about that with the Juniper folks yesterday evening. So it's something that we're scratching our heads with. Anybody else?
Can you see the attenuation model on the map?
Can you see the attenuation model on the map, like when you do the survey, you mean?
Yeah, when you have done the survey, and then things are
Like our working outs of the.
No, you cannot. How would we show it, Eetu? Yeah, like I like that.
Yeah.
I like that. We should definitely at least experiment that. You're welcome to the office one of those days when our chief scientist is there, and we'll strangle that heat map out of him, and But yeah,
he'll love that.
Yeah. Let's make it happen, and actually that would be a really interesting way to see it.
Another question here.
The question was, how can I how does the licensing work? It's bought for one year at a time, but you can every 90 days you can assign it to a different person. So let's say you have 10 of these, on the average 10 licenses, on the average every 9 days you can rotate them around. But every 90 days you can name it to a different person. So if you do surveys very infrequently and it's not always you, every 90 days reassign. Great question. One more question, then we'll be thrown out, which could actually make it a pretty
I think
entertaining.
we were probably trying to be thrown out about 4 questions ago, but
this is true. Doctor in the back row. Great question. Just a couple of things on that. You do not need to, of course, do the surveys or anything to see the live stuff on the map. But survey is kind of a snapshot at the time from the client perspective. The question was, if I heard you right, was do you have to have the exact locations of the clients on the map and stuff like that? What you do need to have is the floor plans need to be loaded to your Juniper Mist dashboard. We can actually push them directly from Hamina when you do your network plan. We can automatically commission the floor plan and even the APs from the inventory to the Juniper system. So there's automatic commissioning. But if you have an existing Juniper system, the requirements are the floor plan needs to be there, the scale needs to be set on the Juniper dashboards, and the APs need to be placed on the map. So the more accurately the APs are placed on the map, the better the whole heat mapping and the client location tracking will work. We actually track the location today using Juniper's XY. So whatever the Juniper system says where the client is, we kind of take that.
Yeah. And obviously that can be more accurate or less accurate depending on what technology you're using from Juniper.
Yep, absolutely. And the AP layout and how dense the network is and stuff like that. I'm afraid to ask any more.
There's one more here, sorry. He wants a hat. So
that's a good question. So as a vendor neutral company, there's several cloud vendors that we support. But today you cannot mix and match. We actually pull in the switches as well. If it's a full Juniper stack, for example, we also pull in the switch locations, which AP is connected to which switch, and some of the switch stats as well. But it does need to be one stack. But since this is an Aruba-friendly environment these days, right?
Sure.
I can say that the next Gen Central, will be supported as well. The current Aruba Central is not supported, but the next Gen Central will be.
He's gonna lynch you.
And with
Thank you very
that,
much.
I shall go and take our beating. Thank you, guys.